Imagine looking down from space on the Earth's North Pole. Tides are caused mainly by the gravitational pull of the Moon. It causes the water on the planet to bulge towards it. It's exaggerated here, but you get the idea. The water is pulled towards the Moon. At this point, it's high water. At this other point, it's low water. However, the Earth rotates, so the level of the tide at these 2 points changes. At one point it falls, while it rises at the other. Roughly 6 hours later, the point that was at high water is now at low water, while the low water point has become high water. This tidal pattern, with 2 high waters every day, is the most common on the planet and is called semi-diurnal. This is how it looks graphically, but it does not apply everywhere. Because the Earth is not evenly covered with water, some places have just 1 high water a day, while others experience very mixed tides. So whenever you paddle anywhere that's affected by tide, and that's most of the world, you need to check the tide times. There are various sources of information. There's printed forms such as nautical almanacs or the small tide tables that you can buy, fishermen's tide tables. Or you can download and print off information from the internet, such as this. You can see the pattern that we talked about earlier. Or you can have tides from a smartphone app, which is quite handy because you usually have your phone on you. However, you could have problems with batteries or with water, and therefore I would always carry printed information as well. The key things we need are the times of high and low water and the tidal range, which is very important, so I better explain that. When the Sun, Moon and Earth line up, the gravitational pull on the Earth's oceans is greatest. It doesn't matter whether they line up like this when there's a new moon or like this 14 days later when it's full moon. In either alignment, the bulge of water on the Earth's surface is greatest, so high water is at its highest and low water is at its lowest. The tidal range between the two is greatest. These are known as spring tides. The name has nothing to do with the season spring, but instead comes from an old Viking word. Between the 2 spring tides is a period when the Sun, Moon and Earth line up like this. These are known as neap tides. They occur when the Moon is waxing in this position and when it is waning in this position. At these points, the gravitational pull on the Earth's oceans is weakest, so the difference in height, the tidal range between high water and low water, is at its least at neaps. Beautiful day, sunshine, what more could I ask for? This is how the tidal range at springs and neaps might look in practice. Let's take a spring tide first, where the gravitational pull of the Sun and the Moon are at their greatest. Low water will be at its lowest and high water will be at its highest. This difference between low water and high water is the tidal range, and it is at a maximum on spring tide. All this volume of water has to flow up and down the coast, roughly every 6 hours, and the speed at which it must travel is also at its maximum on a spring tide. Maximum volume, maximum speed. Contrast this with neap tides when gravitational effects are at their weakest. Low water will be at its highest and high water will be at its lowest. This difference between low water and high water, the tidal range, is at a minimum on a neap tide. Because the smallest volume of water is flowing up and down the coast roughly every 6 hours, the speed at which it must travel is at its minimum on a neap tide. Minimum volume, minimum speed. So that's tidal range. So far we've talked about how the tide goes up and down, and that can be very important when you've got a long walk out on a flat beach. However, most of the time as kayakers, what we really need to know about is the horizontal flow of water, or tidal streams. I'll come back to that later. Meanwhile, let's go back to Gordon and do some more practical navigation.